Hello, this is Professor Brown-Cedarberg, and we're going to take a quick look at a few of the methods within the math class. The math class is here within the Java API, and if we look, here's the Java API, and that's for the Standard Edition 7, and the math class can be found within it. We'll navigate right here, and so we see the documentation for the math class, and there are a number of methods. You'll note that they're all static. We're going to look at a few of them. And so let's do that now. I've outlined a little bit of a program that we'll use to demonstrate these methods. Now, the math class comes with the Java language, no need to import it. All the methods are static, so we don't need to create an instance of the class math. We'll just call these methods with math dot. So you'll see that I've declared a number of variables, and we're going to use those variables in our demonstration. And we're going to look at the methods square root, random, pow, round. There's two versions of that. It's an overloaded method. Max, again overloaded, 4 versions. And min, another overloaded method. There are 4 versions of that. So let's look at square root. And what square root does is it takes in a double, and it will return back a double that is the square root of the argument passed in. And so we will demonstrate that with this. We just call it with math.sqrt, and we pass it a value. Now I can pass it a specific number or a value that's represented by a variable name, so I'll pass it h. Now h we see above is declared as a double. It has 36 in it. Underneath the hood, of course, what's stored inside h is 36.0. And so let's see how this works by simply passing what's given back to us by square root over to system.out.println. And so we'll pass what's given back to us, and I expect that we'll have 6.0 printed to the screen. And we get a clean compile, and let's run it, and we see we do indeed have 6.0. Now, if I wanted, I could pass to math.square root a specific value, and so let's give it 3.33, which clearly is a double, and let's print that out. So we'll have system.out.println, and we'll print out what's returned to us when we call square root, and we call it with math.sqrt, passing it 3.33. Let's see if we get a clean compile here, and then as we run it, we should get that square root to a number of decimal points. Now, be aware that many of these methods that we'll look at have some caveats to them. If we go back to the documentation, here's the documentation for square root, and you'll notice that it has some caveats to it. So it returns the correctly rounded positive square root of a double. There are some special cases. So look into the documentation for that. Now, let's look at random, and random will return a number, a double, somewhere between 0 and less than 1. And so we'll call this one simply with math.random. It takes no argument and returns back a number from 0 up to but not including 1. And so we'll pass what's given back to us on our call to system.out.println, and we'll see indeed that it gives us a number. Each time we run this, a different number. And in this case, it gives us 0.11325, etc. Right? Now, there's a separate video that I've put together on how to use math.random to manipulate the number that's returned back to turn it into an int, etc. But math.random itself will give you a number, a randomly generated number, that is from 0 up to but not including 1. And so then we look at pow. And pow is a method that will return back the first double passed to it. And so we will pass to it the value of, let's see, we'll pass to it, let's pass it B and C. So we'll pass B and then C. So it will raise B to the C. Now, we can print that out. And let's see what we get when we raise B, which is 1.5, to the 1.5111. And so we'll run it, and let's run now. Yep, that looks okay. I'm going to guess it's right. Now, POW takes two doubles. We know, of course, that I can pass two ints to it. And I could pass two ints to it. And I'll do so here. Let's just pass the values E and G. As I pass E and G two ints, E has a value, we'll see, of 2, G of 3, so it'll be 2 times 2 times 2, so I should have 8 printed out there. So let's recompile and run. And as we run, we see that indeed we have 8. So POW raises the second number, raises the first to the second. We can pass in two doubles, but of course we can pass anything further down the food chain, as we can here with random, as we can here with square root. So let's look at these two, which is round. Now round, there's two versions of it. If I pass in a float, it'll return back an int. If I pass in a double, it'll give me back a long. So what I'm going to do is I'm going to call round, and I've declared a couple of doubles up here, one A and one B. So I'm going to call it using these two, this right here. I'm going to pass in a double. So we will pass into math.round the value, let's pass in B. And so I'll pass in B, and let's pass what's given back to us by math.round into system.out.println. And so we'll pass back the rounded value of B. Now B we know is 1.5. So let's compile this, and then we'll run it. And as we run this math.round, passing it 1.5, we'll see that what's printed out is 2. So it has rounded 1.5 up. Now if I were to do the same, that is print out what's given back to me by math.round, but instead of passing B, which has a value of 1.5, let's pass 1.499. I'd like to see how round rounds that number, if it goes from the least significant digit or it rounds as we classically would. You know, if we look at 1.499, most of us will round that to 1.5, and it would become therefore 2. No. What we do is we take 1.499 and we say, that's less than 1.5, it rounds to 1. Although I could write a program that would take the least significant digit, that 5 to the right 9, cascade it through, make that 1.5, make it 2. So let's see what happens when I pass to round the value A, which is 1.4999. So we'll compile it, and then we'll run. And as we run, we see that what we have printed out is the value 1. So I know that this rounding method will round 1.4999 down. It rounds 1.5 up. So it doesn't take the rounding to the least significant number or digit and cascade it through. It rounds starting here. All right. So we see how that method works. Now I can pass in a double or a float, and it works the same way. A double passed in gives me a long back. A float passed in gives me an int. All right. So let's go on to max. Now max takes two arguments, an int, a long, a float, or a double. If I pass in two ints, I get an int back. Two longs, I get a long back. Two floats, I get a float back. Two doubles, I get a double back. And what it does is it gives me the greater of the two numbers. So I call it with math.max. And let's pass into it, we'll pass in D and E, which has the values 1 and 2. So I'll pass in D and E, and again I can pass in specific numbers or variable names. And I think that with D and E it should give back to me the value 2, which is the max of those two. So let's print that out. And so we will print out what is returned back to us by math.max, passing it D and E. D has a value of 1, E has a value of 2. I should get 2 back. So let's compile it, and then we'll run. And when we run, indeed what's printed out is that value of 2. Now I can use max to find the greater of any number of numbers. I only have max that takes 2 arguments in, but I can write a bit of code that will actually find the max of not just 2 but 3, 4, any number of numbers. Let's say I'm going to call math.max, and I'm going to pass it D and E as I did before. So I'll pass it D and E. Now I know that will give me back the greater of those 2 numbers. But let's say I want to find the greater of the numbers D, E, and G, right? All 3 of them. So what I could do is call math.max, get a value returned, compare D and E, and then have that compared with another value. So I'll compare it with G. And what I'll do is I will pass those 2 numbers as the argument to another call to math.max. So here I'll call math.max, and I'll pass to it what is returned back by math.max DE and then the value G. That will return back the greater of those 3 numbers, D, E, and G, that I know that should give me back 3. So let me pass all of that to system.out.println, and I'll pass it here like that. So let's compile. Oh, we forgot the S. Let's do that. We'll compile, and I should have the last number printed would be the maximum of D, E, and G. And as I look at D, E, and G, I should have printed 3. This math.max found the greater of those 2. That result was then passed as the first argument to this call to math.max, the second argument being the G. So I'm able to find the greater of 3 values, and I can carry this out to any number of values using the method max that takes in 2 arguments. Min is the flip side of max, and I'm just going to do some copying here. And what min will do is return back the minimum number of 2, the 2 that are passed to it. And I see that I can pass 2 ints, I get back an int, 2 longs, I have returned a long, 2 floats, a float, 2 doubles, a double. And I'm just going to cheat a little bit. I copied and pasted. And so I'll find the min of D and E. And with our values of D and E, we know that I should have returned 1. And when I pass D, E, and then G, I should get, again, 1 printed to the screen. So let's see how this compiles. And then we'll run it, and I should have as the last 2 numbers printed to the screen should be 1s. Oh, it's 2, because I've made a mistake here and not corrected that to be min. So let's try that again. Here we go with compile, and then we'll run. And now I do indeed see that the last 2 numbers printed are 1. The min of D and E, and then the min of the result of min D and E, with G as the second argument. So that's a quick look at some of the methods of the math class. There are a lot of them. They're very useful. I suggest you discover them through the Java API. And I thank you for watching.